For the second video of Notes 45, this is going to be a combination of a few different problems, but going through this front of the note sheet. So problem number 2 is what we're going to start with, and it says to solve using the quadratic formula. Now, conveniently, the equation is already given in the form that we want, which is ax squared plus bx plus c is equal to 0, which means that we're going to use an a value of 4, a b, right, b, there we go, b value of -3, and our c value is going to be -9. So as long as we're in this standard form, so right, x squared, x, then our constant, we can just grab the coefficients, so a, b, and c. And as a gentle reminder, the quadratic formula, when we are solving for x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Now, that's what the quadratic formula looks like. It is a giant substitution problem. And what I'm going to do with this giant substitution problem is I'm actually going to erase things and replace them as I go. So b here and here, I am going to replace, first of all, with parentheses, but then I'm going to fill in a -3 here and here. And then the a values here and here, I'm going to, again, put in some parentheses because we're going to use those for multiplication, especially in the case of this 4ac. A is 4. And then last but not least, the little c at the end there, I am going to replace that with our lovely -9. All right, so let's see what we got here. If we simplify this mess, so we have in the first part here, the opposite of -3 or -3. That's going to become +3, plus or minus. I write huge, so I'm going to give myself space. Might not be enough, but we'll see. We're going to do -3 squared. That's going to make me a +9. Now, this multiplication is kind of a mess, but I'm going to take it apart in pieces. So I'm going to do -4 times 4, which is going to be -16. Then I'm going to take this -16 times -9. So let's start with, I know that's going to become positive. So let's see, 16 times 9. All right, 5, 4, whoops, hold on. That's supposed to be a 4. That's the 5. Well, that's 54. And then, yeah, that's 144. All right. If you are able to use a calculator, obviously that's going to make this number a lot easier to find. But just working that out in my head and then on paper is also helpful too. Let's see, 2 times 4 in the denominator is going to be 8. All right, so let's go ahead and work with this 9 plus 144. So x is equal to 3 plus or minus, it's going to be 153 over 8. Let me grab a calculator here just a second. Let's see if I can get a calculator going there. All right, cool. So we're going to clear out that mess. And I feel like 153, let me try and divide by 9. Ooh, it did work. All right, I wasn't sure about that one. So here's the thing. Normally I solve this with a perfect square, or square root or factor tree. But what I'm going to do with this one is, whoops, apparently I'm going to throw my screen around is what I'm going to do. So I'm going to deal with 153 here. And this is really 9 times 17. So I've got the calculator handy just to reassure you. If I take 9 times 17, that's the 153 I'm looking at. Now, why do I care that this is 9? Because this is a perfect square. And the square root of 9 is 3. Root 17 is going to stay root 17. So that's, I'm going to leave that. So instead of writing the square root of 153, I am going to replace it with what it simplified to. So this is going to be 3 plus or minus 3 root 17 all over 8. And that should be the final answer for problem number 2 there. All right, so let me go ahead and get rid of the calculator. So that is the answer for number 2. I'm going to go ahead and move on down to problem number 3, which is graphing some conjunctions and disjunctions. So problem number 3 is a conjunction. So -7 is less than or equal to x, and x is less than 3. So on my number line, I, of course, need -7 and +3. So from -7, if I want -7 to be less than or equal to x, that means x needs to be greater than -7. So I'm going to be shading to the right of -7. At -7 itself, I'm going to use a bracket, right? Because that's the equal to part of our inequality here. And then I want to graph x is less than 3. So I'll pick a different color here. From 3, I'm going to shade to the left because I want to be less than 3. At 3 itself, I'm going to use a parentheses. And as we've talked about, when this is a conjunction and we've got an and here, we want to look for that overlap. Kind of a weird purpley color in the middle there. So our inequality starts at, our double shading here starts at -7, and it continues until 3. -7 gets the bracket, and 3, of course, gets the parentheses. So yes, I know the direction said to graph. Part of graphing is also writing the interval notation. Okay. All right, question part B here is a disjunction. I have two inequalities that are joined with or. So I'm going to start by graphing this. And on my number line, I want to be super careful that I need a 5 and a 2, but 2 is going to be the left of 5. So make sure you do fill that in accurately when you're making your number line. So the thing that we're going to be looking for here is I want x to be greater than 5. So from 5, I'm going to shade to the right. Those are going to be values greater than 5. And at 5 itself, we're going to use a parentheses, no equal to. And then I want x to be less than or equal to 2. So from 2, I'm going to shade to the left. But at 2 itself, I'm going to use a bracket. Okay, there is an equal to component. Because this is a disjunction, I'm looking for just any shading whatsoever. And so I have a chunk of shading over here on the left, and I have a chunk of shading here over on the right. And so I want to make sure I include both of those. So starting with the far left, that's going to be -infinity to 2. All right, with a bracket at 2, union. Okay, we have two parts of the interval here. And then our interval is going to pick back up with our shading at 5 to infinity. So again, we've got the graph for the disjunction and then the interval notation for our disjunction. All right, last one for this video, I'm going to solve and graph problem number 4. Now, problem number 4 is a conjunction, all right? But the problem is this conjunction does not have an x in the middle, and I want it to just have an x in the middle. So I need to get rid of this times by 3, and I need to get rid of a -4. So we're going to start by solving like I would normally. I'm going to add 4. But here's the thing with a conjunction. It has 3 components to it. So when I'm going to add 4, I need to add 4 to all 3 components. All right, please make sure you do that. So let's see here. 2 plus 4 is 6, less than, whoops, I don't know why I'm putting an equal to sign there, less than 3x. -4 plus 4 is gone. Less than or equal to 8 plus 4 makes 12. I'm going to go ahead and divide by 3 to get x by itself. But again, I need to divide all 3 components by the number 3. All right, so 6 divided by 3 is 2, less than x, right? 3 divided by 3 cancels out. Less than or equal to 12 divided by 3 is 4. So now I have a conjunction. 2 is less than x, and x is less than or equal to 4. So on my handy dandy number line, I need the number 2, and I need a 4. And from our first inequality here, I want 2 to be less than x, which means I want x to be greater than 2. So I'm going to shade to the right. At 2 itself, though, I'm going to use a parentheses, no equal to part. And my second inequality is I want x to be less than or equal to 4. So from 4, I'm going to shade to the left. That's less than 4. And I want to use a, what is that? A bracket at 4 because there is a parenthesis section. So not the most high contrast here, but I have this part in pink And I have this part in yellow, and kind of right in the middle here is this orangey-ish color. That's the overlap that I'm going to be looking for a conjunction. So shading starts at 2, parentheses, ends at 4 with a bracket. All right, and that's the answer to number 4 there. So I'm going to go ahead and cut this video, and I will come back and do a separate video for the last part of notes. I believe this is 45. As always, let me know if you have any questions or concerns, and I'll see you in the next one.